we've made it to the last section. Let's start on the first page. This is lesson 19.5. And in this lesson, we have a combination of and probability as well as or probability. So, and we also have independent events and dependent events. So we're going to have to look at each problem to decide whether we use the and rule, the or rule, and whether the events are independent of one another or dependent. So let's begin on the next page with problem number 2. Right. In problem number 2, we have a game that includes a deck of cards with an animal picture on each card. And you'll see over here on the right, you'll see what's in this deck of cards. The table shows the number of each type of card, and when a card is chosen, it is not replaced in the deck. So when I take out a card, I'm not going to put it back in the deck. Therefore, these are dependent events. So I'm just going to write that over here to remind me. All right. So the first question is, we're going to select 2 cards, and we want to know what the probability that the first card will have an elephant on it and the second card will have a lion on it. So we're going to use the and rule. So let's begin with the first card being an elephant. So if I look at my chart, there are 12 elephants out of a total of, now we have to add up all of these to see what it adds up to. Let's move this over right here. Let's see, we have a total of 40 different cards. So 12 out of 40 have a, let's see, an elephant. So that was my first one. Now we need to find the probability of the second card will have a lion on it. So if I look at my chart, there are 8 cards that have a lion. But now, since I have not replaced the first card that I pulled out, it would just be 8 out of 39. So using the and rule, we're going to multiply and find the product of these 2 events. Once again, we're going to pull out 2 cards in question B, and we're looking for the probability that the first card will have a monkey on it, or the second card will have a panda bear. So we need to change rules. We need to use the or rule. So the first card is a monkey. In my chart, there are 10 cards that have a monkey out of 40. The second card has a panda bear. There are 4 cards out of 40 that have a panda bear. Now let's just go back and remind ourselves, when we use the or rule, this is the probability of event A plus the probability of event B completely on its own, not having taken into consideration that event A has occurred. And then we need to subtract the probability of event A and then event B, given that A has occurred. So the probability of event A is 10 out of 40. The probability of event B is 4 out of 39. pulling out 3 cards. And we're looking for the probability that all 3 cards will have a lion on it. So when I think about this problem, I want to know what is the probability of getting a lion, and then getting a lion, and then getting another lion. So we're going to use the AND rule. So the probability of picking a lion first, there are 8 out of 40 cards that have a lion. Now, the probability that I pick a lion the second time is only 7 out of 39. Since I pulled a lion the first time, that leaves only 7 left in the bundle out of only 39 left in the pile. And then the probability of getting a third lion, I'm now down to 6 out of 38. And the probability of each of these occurring is the product of those 3. All right, we're back to drawing out 2 cards. We're looking for the probability that the first card will have a panda bear on it, or the second card will have a giraffe on it. So we're going to use the OR rule, starting with the probability the first card will be a panda bear. So we have 4 panda bears out of 40 cards, plus the second card is a giraffe. There are 6 out of 40 cards that have a giraffe, minus the probability of event A and then B. So the probability of event A is 4 out of 40, and then the probability of B happening is 6 out of 39, since I did not replace it. Okay, we're going to pull 3 cards, and we're looking for the probability that all 3 cards will not display an elephant. So this would be the same as pulling a card that's not an elephant, and then pulling another card that's not an elephant, and then pulling a third card that is not an elephant. So we're going to use the AND rule. So the cards that are not elephants, well, let's go up here. There are 12 cards that are elephants, so out of 40, that means that there are 28 that are not elephants. So the probability of not getting an elephant is 28 out of 40. Now I'm going to pull that card out, which leaves only 27 out of 39 that are not elephants. Once I select that card, that only leaves 26 out of 38 that are not elephants. And the probability of that is the product of those 3 fractions. A child draws out 2 cards in part F, and the probability, we're looking for is that the first card will have a lion on it, or the second card will have a monkey. So we're back using our OR rule. So the first card has a lion. That's 8 out of 40. The second card has a monkey. It is 10 out of 40. And the probability of the first card being a lion and then the second card being a monkey is only 10 out of 39. Number 4. Now, right above number 4, it says in a box, determine the probability that each compound event will occur without replacement. So as I draw something out, I am not replacing it back in to the set. So let's take a look at number 4. It says you randomly choose 3 shapes from the set, one after the other, without replacement. So I just want to underline that and emphasize that. What is the probability that the first shape is a triangle, the second shape is a cube, and the third shape is a cylinder? So as you can see, you can probably figure out we're going to use the AND rule. And so let's start with the probability of the first shape being a triangle. Before we do that, let's see how many there are altogether in this set. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. I'm going to say that there are 22 in this set. Let me try that again. 2. All right, that looks about right. The probability that the first shape was a triangle, and I think what they meant here, since there are no triangles, there's some pyramids. I'm thinking that they meant a pyramid. So let's count the pyramids. So 1, 2, 3, 4, 5. There are 6 pyramids. There we go. And there are 22 total. Now, I want to know what the probability is that the second shape is a cube. So there are 7 cubes. Now, what I have to remember is when I took out the first pyramid, I did not replace it. So now there are only 21 shapes left in that set. And then finally, the third shape is a cylinder. And there are 9 cylinders. And because I did not replace the cube that I just picked out, there are only 20 shapes left. And we're going to multiply, find the product of those 3. teacher is dividing the 24 members of a class into groups to work on different projects. The letter A, B, or C is written on each of the 24 cards. And then the cards are placed in a box. There are 8 A cards. There are 6 B cards. And there are 10 C cards. Each student randomly draws a card from the box without replacement. And determines the student's group assignment. What is the probability that the first student will draw out an A, or the second student will draw out a B? All right, so we're going to definitely use the OR rule, and these are dependent events. So let's begin with the probability of selecting an A. There are 8 out of 24 cards that are an A. And then the second student will draw out a B. There are 6 out of 24 cards that are B. And then we're going to subtract the probability of event A, and then B would be 6 out of 23. Event A and then B, given that A has occurred. I see where I made a mistake right up here. I entered a minus sign where I should have entered a multiplication sign. So let me clear that and we'll try that again. All right, there we go. Number 8, Michael wants to know the height of his school, and he places a small mirror on the ground between himself and the school. Then he backs up until he can see the highest point of the school in the mirror. So what you'll notice here is that we have 2 triangles. We have 2 triangles that are similar to each other. And the reason why they are similar is by angle similarity. They both share a right angle in common. And then they both share this angle here, where he uses the mirror on the ground between himself and the school. So I can write a proportion to help me define x. So x in the large triangle corresponds with 6 in the small triangle, as 93.5 in the large triangle corresponds with 12.75 in the small triangle.